You've seen these equations before, all right? That was at the end of what we've, it's kind of this little review. And a lot of these notes will be on the test in different ways, okay? Multiple choice, short answers, or questions like one of the questions that a lot of people got wrong yesterday in that lab, not a lot of people, just a couple. If I heat up most things when I heat them up, you're all looking here. Most things when I heat them up, I'm adding extra energy and it turns into a solution better. So I can dissolve more if I have it in hot water. But I asked you about a guy like sodium hydroxide who got hot. That meant he was like this. Actually, if I heat up a solution of sodium hydroxide, it's actually going to dissolve less. It's kind of weird. All right. But anyway, sticking with the same theme here, I'm going to show you a little video clip of a supersaturated solution of sodium acetate. Now, sodium acetate, like most things, when you dissolve them, it's an endothermic reaction. So what they did, you'll see how it does it here. It takes energy to turn them into solution. It absorbs energy. So guess what? If this stuff comes out of solution, it turns back into a solid, and it turns back, then what do you think is going to happen? Energy is going to be what? Released. Yeah. And that's why, as you'll see, and turn that light off in this video clip, this stuff is actually gets hot. It's actually called hot ice is the name of the demo. All right? Instant hot ice. Because when it turns back into a solid, comes out of solution, it actually gives off the heated surface. You make it super saturated by using hot water, and then you cool it down to the freezer, the whole fridge. I like this one. Check this out. I just did, right there. I like the music, that's my music. It's very similar to that seeding thing we did, remember? It was not actually coming out of solution. It wasn't actually freezing in the case of my seeding one until it got a crystal. They just poured that over a crystal and it basically all comes out of solution and solidifies there. So you're pouring it over some solid sodium acetate. Pretty cool. Okay, now that's the end of turn it light off. That's the end of the note parts, really. From now on, we're going to be doing problems. Okay, and the problems we're going to be doing are first going to start out with kind of like reactions, writing equations, and then we're eventually going to get to next week sometime actual math problems where we're calculating concentrations of solutions. Okay, let's start out with this though for today. Solubility and precipitation. We're only going to get to the solubility ones first. And they're going to be more reactions. But from now on, everything we do from now on is pretty much going to be problem-oriented. The amount of notes you got, well, there's one more day maybe, or a couple of boards, or board or two of notes on electrolytes. But for the most part, they're over. And I told you, this test is not like the last one in that it's not 85 or 90% questions, but rather about maybe 70%, 75% problems. Maybe even less than that, though, I guess. I don't know. I have to look at the numbers, but there's both. Okay, let's talk about solubility first. We're going to have to use a chart. In the chart you do have, I need you to look right now in your notes or notebooks for the chart. Remember the water vapor pressure chart I gave you? Remember that chart? It looked like this, water vapor pressure chart. Find that, because in the bottom of that chart was actually the chart we're going to need for today. By the way, I did like that song on there. I found that years ago, and I downloaded it way before there were, it's actually on a free play thing. It's called Clear, I think.
Ironic.
Ironic. Isn't it ironic? No, I think it's covalent. Anyway, ionic. All right, if you look at this chart, we're looking at the bottom half of the chart now, and it's got ions and then letters in there. What the heck does that mean? Let me explain. No time to explain. Let me stop. You ready? If I asked you to write the solubility, to tell me the solubility of salt. Now, we all know salt dissolves in water, but I want, you're not going to know most of them. Look it up on the sheet. Find sodium down the left side and chloride across the top. Do that now and see what letters there emulate. You were zoned out. That's what. And you know what?
No.
Yes. Okay, everybody's looking for sodium chloride. What letter do you see next to sodium chloride? Yeah, you see a big capital S. Now that is, by the way, believe it or not, going to get confusing. Right now it's not. S stands for soluble. Very simple. So that guy is soluble. Well, let's look at some of the other letters we see there. Check out this guy, AgI. If I asked you, is silver iodide? Beware the iodides of March. If you're all in toga. So. Although I got to tell you, Jared, that's like the worst. It's like, what, did somebody kill you?
No, I killed Caesar.
Oh, all right. Okay, you killed Caesar. All right. I thought you were Carrie for a minute.
I get it. I read that book.
Yeah, well, it's not just a book. It's like blood.
I don't like the movie, though.
Yeah, I never saw it. Anyway, AgI. Look him up. Silver and iodine. What are you going to find? Beware the ides of March. So iodide of March. Apparently, Caesar should not have had the negatively one charged ion of iodine. Iodides of March. It's really not funny, but I'm going to keep saying it. I'm going to find a way that it's funny. All right, what letter is next to him? A big capital I, which means he's insoluble. Well, that's simple enough, but you can see there's a lot of other letters there. So let's look at some of the other letters. Like, for example, if I have BaSO4. If you look up BaSO4, what letter is there? Barium on the left, sulfate on the top. What do you get in the chart?
A little A.
A little A. Well, I don't really care. Let me say, I'm going to cheat here, guys. As far as we're concerned, I'm like, what is that, a siren or what? Yeah. As far as we're concerned, people, any letter other than S on that chart, as far as we're concerned, means he's insoluble in water. That's all we're going to care about. So we just care that he's insoluble. That's all you're going to have to worry about. You understand that? I know it's a bit of a cheat, but that's okay, because we're just going to be saying whether we have a precipitate form. We're going to be eventually predicting that, and whether something dissolves in water or not. When we do in Chem 2, when we talk about KSP and all kinds of other solubility product constant and stuff like that, we can predict even the amounts that will tell us whether it's soluble. But we'll get a lot more detail. But for now, I just care about S for soluble. Anything else, any other letter you see there means insoluble as far as you're concerned. It means it won't dissolve in water. Okay? Good enough. Now, time to learn how to write what are called dissociation equations. This is what I said. The rest of this chapter is going to be all problems. Well, it doesn't mean they're going to be math problems, but they're going to be problems. I want you to write a dissociation equation for a bunch of compounds today and on the test as well. What happens in a dissociation equation is the ions separate when you put them in water. If it's soluble, only if it's soluble. If it's not soluble, you're not going to write one for it, because it means it doesn't dissociate in water. So if I add a soluble ionic compound to water, and he dissolves in that water, I will get ions. The two ions in general that make up the compound. In the case of a guy like salt, I want you to finish this equation for me. This is where it's going to get hairy. Because you're about to do something that I specifically yelled at you for doing just a few months ago. If, now, I don't want you to write this, but if you had done this last chapter, not last chapter, but whenever we first learned this, I would have yelled at you about it. You would not have done, again, don't copy this. You would not have done Na plus Cl, right? What would you have had to have done?
Diatomic.
Yeah, chlorine's diatomic, so it's Cl2, put a 2 over here and a 2 over there. And that's the correct answer for everything we did up to today. That's not the correct answer for what I'm going to do today. And here's the reason why. This is a chemical equation. Don't write this down. Not writing anything I'm saying down. This is what it would have looked like a few months ago, yesterday, if I was talking about a chemically breaking down salt into its constituent elements of sodium, metal, a solid, and chlorine, a gas. That's what the G and the S stand for. But that's not what I'm doing when I simply take, here, let me do it for you. Let me see if you notice any chlorine gas being given off. Okay, here we go. Here's my salt. Here's my water. You see any chlorine gas given off? I don't see any chlorine gas given off. Do you see any sodium metal forming? You know it, because we put sodium in water before. What happens when sodium hits water? It catches on fire and it runs around and it explodes if you put enough of it into it. Obviously, this is not the same as that. This was all well and good when we were talking about chemical reactions, composition, decomposition, replacement, and exchange. Now, we are talking about dissolving stuff in water. And although I use the form of a reaction in it, it is not a chemical, but rather a physical change, where we're just breaking up the ions, dissociating the ions in solution. So what you are going to write down is not this, but this. I'm going to write it below it. You never write this, because that'll just confuse you later. Okay, just write what I'm about to write below it. And you already have the NaCl written down here. In the presence of water, you can write the water above it, breaks up into exactly what I would have told you not to do back then. Sodium ions and chloride ions. I would have yelled at you for doing that. But chlorine's diatomic. Why don't I put a 2 there? Because he's not chlorine gas. Now, how do I show that he's not chlorine gas, but rather chloride ions? I put a little AQ next to him and a little AQ next to him. You may have seen those letters hanging out. S, G, L, AQ. Hanging out on a lot of our problems in the book. And I know some people asked me about it over the course of the last few months. And every time he did, I just said, well, don't worry about it. They just mean what state it's in, but that's not important right now. And it wasn't important. Now it is. Because that's the difference between a physical change, okay? Don't write this, but that's a physical change versus a chemical change, all right? This is a physical dissolving in water. This is a chemical change. And you see the difference. Sodium metal is NaS. Sodium ions are Na plus 1 AQ. Chlorine gas is Cl2G. Chloride ions, which are in this water I just added salt to, lots of chloride ions in there. A lot of people, remember that video I showed you after I added the sodium in there? I showed you a video of potassium thrown in water. The guy had to run away because it blows right up. Remember that? But there's potassium in bananas. So if I run my banana underwater, it's going to blow up? Why not? Because there are potassium ions in bananas, not potassium metal in bananas. That's the difference. Why didn't this blow up and give off green chlorine gas when I put salt in here? Because it's chloride ions, not chlorine gas. Okay, that's the difference between. Now that's what we're doing now versus what we did for the past 6 months. Okay, all right, let's do a couple more. Let you work on it for problems, for homework, and see how it goes. Try this guy. K2SO4. What do you think K2SO4 is going to break up into?
K plus
Absolutely not.
KO.
Nope.
Um,
What is she forgetting to do? And I purposely didn't remind you to do. What do I have to look up about K2SO4 first? I told you to get those sheets out for a reason. Are you sure K2SO4 is soluble? Look them up. Is he soluble? Is there a big S next to him? What letter's next to him? Yeah. I'm not going to do anything for this guy. I'm only going to do soluble salts. You're just going to do that for me on the test. That proves to me, shows to me that you looked it up and you know he's not soluble in water. Now again, remember, those other letters do mean other things, and we could play around with them. We will in Chem 2. As far as we're concerned in Chem 1, they're either soluble, and I do this dissociation equation, and they're soluble in water, or they're not. I don't care about little soluble in acid or partially soluble or whatever. They either are or they aren't. Okay, so let's do the next one. That's done. I don't have anything else to do on that guy. Will there be something like that on the test and on the worksheets I give you? Absolutely. Try this guy. Magnesium chlorate yield. What do you have to do first? No, not right. What do you have to do first? Make sure he's soluble. Look up magnesium and look up chlorate. Is magnesium chlorate soluble? Is there a big S there? So now I can finish it. What's magnesium chlorate going to yield? What's that?
Magnesium ions.
Magnesium? Just magnesium ions?
Plus chlorate.
Yeah, plus chloride ions.
Can I interest you in dividing this pie for the NHS?
I can't right now. I'm taping my class. And besides, thank you. Magnesium chlorate would break up into magnesium and chloride. Now, I want you to stop you right now for a second. Do you realize how many times I did pretty much the same kind of example? Potassium chlorate yields, something like that, sodium chlorate yields. And you know what you wrote back then? On your common ion sheet, you wrote potassium chloride plus oxygen. Remember, that was the chemical way it broke up. I yelled at you if you did something as stupid as write magnesium plus chlorate. I yelled at you. But that's what you actually do now because it's not a chemical reaction. It's a physical dissolving in water. Magnesium aqueous ions, AQ. Chlorate aqueous ions, AQ. Little AQ after each of those.
We don't have to make it into like a. We don't have to do like MgClO3.
We are. Yeah, we're not done. That's just the words.
Okay.
By the way, for every one of these, that's why I've up till now, the first two I kind of did pretty quickly. But these next two, I think I have one more after this. I'm not positive, but maybe the last one. This one or the next two are what I really want you to do on the test and on the homework. You need to write and complete the word equation and the formula equation. So I got to look up magnesium and chlorate. What do you need? Your common ion sheet, because you probably don't remember what chlorate was. Maybe you do. Who remembers? Well, everybody knows what magnesium is. Look at the periodic table. Mg what?
+2.
+2. Chlorate? CO3, L3, -1. Some of you remember it without looking it up because we did use it so often. Writing it correctly?
2.
You did 2. And I put a little S next to that, right? Little S. That means that he's a solid. I have this solid magnesium chlorate in my hand. And I throw him in water. What do I end up getting? Magnesium ions. And by the way, I should do this right now. This is what I'll get for a bad answer. Okay? Now, what's wrong with that? Several things are wrong with that. What's one thing? You did what I said to do, magnesium plus chlorate.
It doesn't have the AQs.
It doesn't have the AQs. That's actually one of them. Yep, absolutely. A little AQ next to each one of them. What else doesn't it have?
There's no oxygen.
There is oxygen. ClO3, ClO3.
There's no I.
Are you saying there's no oxygen as magnesium chloride plus oxygen? Because that's not what's happening. I just said that's not what. It's not a chemical reaction.
No oxygen is released.
There's not supposed to be any oxygen release. It just breaks up into magnesium plus chlorate. All right.
Have it like plus.
I don't have the charges, +2, -1. So my point when I said about in the old days, when magnesium chlorate broke up, I had you look up magnesium chloride plus oxygen because that was a chemical reaction, which we are not doing now. That's the point. You got to get out of that. You got to get out of that mindset. Still one more thing wrong. What's that? It's not balanced. I got 2 chlorates here. I need a 2 there. Got it? Now is it correct? Yes. Okay. And by the way, I know that looks ugly, but that's an S. That's an S. So S stands for solid, AQ for aqueous, okay, G for gas. I think I have one more. Not positive. Let's see. Yes, I do. Why don't you try this one on your own? That's a good idea. We'll take a few seconds here. Try this one on your own, and then I'll do it on the board and see if you get it right. It's about as difficult as I can make it. What had you better do first? Look it up. Should all have that much at least, right, by now? Aluminum plus sulfate, because it is soluble. Little AQs after them. Look up the charges, but don't just look them up. How many people, I can't tell you. Look up the charges and leave it like that. Okay? Okay? Everybody look good there? And finally,
Balance.
yeah. How's that? Pretty good, huh? Okay. All right. That's what your homework's going to be like tonight. But how much time we got? Before we do that, I'm going to actually, the homework is, do I have it on there? No, I don't. The homework's over here. It's just page, it's number 89. Don't start on that. These 5 are going to go on the back of this sheet you did yesterday.